Okay, good afternoon, everybody. Can you hear me? Just do a sound check. If you can hear me, raise your hand. Okay. If you can hear me, raise your hand. Okay, good. Thank you. Okay, good afternoon, and thank you for joining us. My name is Chuck. I've got two screens, so I just want to check. You should be seeing the screen with the slide called Infrastructure as Code, Declarative or Imperative. Is that correct? So raise your hand if this is correct. So I make sure that I'm sharing the correct screen. Okay, that's good. Thanks. Right. So if you want, if you want to have access to these slides, you can go to the link down here below, bit.ly/I_A_C. Okay. So you can join the slides, and there are some information. There are some information on the slides that you can get, especially the code. And also, you can ask questions. Put them in the chat, and I'll try to answer them. Or if it's really urgent, you can unmute yourself and ask me during the presentation. I think the other thing that I tend to do is I tend to speak a little bit too fast. So if you want me to repeat something, just unmute, and just say, ask me to repeat myself. Okay. So yeah. Okay. So the agenda today is we're going to talk briefly about we're going to talk about infrastructure as code. This will be an introduction to infrastructure as code. We will look at what is infrastructure as code for those of you who do not know what it is, and then we'll look at some tools, and then I'll show you how to use two major tools, to deploy an application. So it will be demo, and we will deploy the hello world of IAC. The code, the repository, the code will be available here. Okay. So after the workshop, I will push the code to this repository, so you can go and get it. Let me see if there's anybody still waiting to get in before I. Okay. So let's start. So the idea is this, right? Today, if you want to deploy an application, for example, like maybe a RabbitMQ or or WordPress or Jenkins, or Tomcat. Not so long ago, what you need to do is this. At least during my time anyway, about 10 years ago, you need to go to my boss, ask for approval, write a justification, and then go and get three vendor code. After once you've evaluated them, fill in the purchase order, send it off. Wait for a while for the hardware to be delivered, and then you assemble them. You put in your hard disk, you put in your memories, etc. Then you need to find space in your data center. You need to go and physically put it in, connect it up, test everything, right? So the duration, by the time from starting the idea, where you have an idea to deploy an application, right down to the hardware ready, typically about 4 weeks, right? Maybe even longer. Today, what you really need to do is this. You need to get a browser, go and sign up, in one of the cloud provider, GCP or Azure or AWS or DigitalOcean, and open your browser, right? Give your credit card, just go to the browser, click, right? And then you get your infrastructure provision in about 15 minutes. So that's a really, really big difference from a few weeks to 15 minutes. Okay. So what actually made this happen? So what we have seen over the last 10 years is this: all the hardware, right? All the IT components like your servers, your network, your routers, your hard disk, right? Your firewall, they've all been virtualized, right? In a sense that they have all now they are all now being managed by your public cloud providers, or even if you got VMware, running on-prem, they are all being managed by that. So in our case, we are talking about public cloud providers, right? AWS and Oracle, DigitalOcean, etc. Okay, And so these guys, these public cloud providers, they manage this, right? And the way, if you are a consumer, if you're one of their subscriber, the way you consume these resources is, what these guys do is, the cloud provider do is that they provide an API, typically a HTTP, a RESTful API, which they write a web application over, right? And so the web application will provide you with a form, and then you click a few things, you say create. The web application sends a post request through the endpoint to the cloud provider, and then the cloud provider make all that happens, right? So really, what allows this flexibility, right, is the management of the cloud providers and the API that they provide, okay, that allows this to happen. So the idea of infrastructure as code is this: since the cloud provider has already provided the API, right, we can actually leverage this API using a variety of tools, right, like a curl, like the curl command line or Python, or even specific tools like Terraform to help us make calls to this API to provision resources, to install software, to configure our resources. Okay. So why would you want to do that? Okay, so why would you want to be able to write this script? And this has become very popular now. So why would you want to do that, right? So first of all, right, when you write a script to provision something, even writing a simple script like a curl command to provision a hardware, what you are really doing is this: you are really describing what exactly you need to provision. Okay, unlike in the old days, where I have to tell the admin person, hey, I want a server, with let's say with 16 gig memory, right? So even when I say I want a server with 16 gig memory, it is not very clear what sort of server do I want. What is the CPU? What is the operating system I want, right? But if you script this and you say in a script, you say, I want a server of this size with this much memory, with this operating system, you are saying exactly what you need. Okay, so your script, just like the program, captures the environment, and there is no ambiguity. Unlike English or communication, there is no ambiguity. Okay. Secondly, the script, right, actually freezes your infrastructure along with your code. Now remember, the infrastructure, the purpose of the infrastructure that you're provisioning is to support your code, your application. Today, our application, if you're using, if you're writing in Python or you're writing in JavaScript or Java, they've got this file called package -log.json for Node application, requirements.txt for Python application, and pom.xml or Gradle for Java application. What these files actually capture, right, are the dependencies and the version, hard-coded version, right? So these requirements actually freeze our application. So we know that every time when we build the application, we will not, it will run. So when we write our infrastructure in a script, what we are also doing the same thing. We are also freezing the infrastructure along with our code. So we are saying that, for this infrastructure, right, for my code to run, this is exactly the infrastructure that I need. On this particular version, this much memory, this much hard disk, and this particular version of the OS with this OS patches. Okay. The other thing that is really good with IAC is that now for the first time, right, if you are a developer, there is now parity between your development machine, your testing, and your deployment. The infrastructure, the machines are the same, although the number of CPU, the memory can be different, but the operating system, the way it is set up, can be exactly the same. Okay, so you are now actually testing, you are now actually deploying on what you're going to what you're going to develop. Okay. Finally, one of the things that people talk about, treating your infrastructure as code, what they really mean is treating your infrastructure, those infrastructure script that you write, like your application. So what do we mean by treating that like our application. So how do we treat our application? Right, with our application, what we do is that we have version control, we do testing, we do unit testing, we do end-to-end testing, we do linting, we run our lint tool over it. We create abstractions by creating reusable components. We apply best practices. We've got patterns, right? So all this good stuff, great stuff that we have learned over the last 50 years on software development, we can now apply the same thing onto the infrastructure, onto the infrastructure that runs our application. And finally, of course, the speed of just setting up and tearing down complex environment very quickly. The real benefit of this is this, like I said, when you're doing testing, very often, today when we do testing, right, we don't really test on what we're going to deploy, the environment that we're going to deploy. With IAC, we can actually now do this, right? We can set up an ephemeral infrastructure just for testing. The setup is the same, but maybe the number of instances of your VM could be less, the memory could be less, but the setup, the structure is the same. So those are some of the benefits. There are a lot of tools. So there are a lot of tools that allow us to do this, here, right? Two of the one that I actually use quite a bit. The first is Terraform. The second is Pulumi. Most of you would have heard of Terraform. Maybe one or two of you may have heard of Pulumi. Okay. So let me go through them. Both of these two are IAC, infrastructure as code, and they are both cross-platform and open source. Open source means that they are available publicly. You can look at the source code. Cross-platform here means they allow you to create. They allow you to provision to multi-cloud providers. So in other words, Terraform will support GCP, AWS, DigitalOcean, right? Same as Pulumi. So they are cross-platform. They are multi-cloud. Secondly, they run on Linux, OS X, and Windows, right? Unlike some IAC tools like Ansible, for example, Ansible doesn't run on Windows. Ansible runs on OS X and on Linux, right? But both of these two tools run on all the common operating system. The difference is this: Terraform uses a DSL to script your infrastructure. A DSL is a domain-specific language. In other words, Terraform has its own language to describe the infrastructure. Okay, it's called HCL, HashiCorp Configuration Language. I think that's what it's called. Pulumi uses general purpose programming language. So the four language that it supports officially is JavaScript, TypeScript. That's one language. Golang, Python, and C#. Okay. So in other words, what Pulumi does is this: Pulumi creates libraries that you can call from this programming environment. There are other examples in the Terraform camp that uses DSL. One example is the Azure Bicep or AWS CloudFormation. So these are examples of DSL. However, the difference is this: the Azure Bicep and the AWS CloudFormation is specific. They are not cross-platform, right? They are not cross-provider. They only work with Azure or AWS. And on this side, on the general purpose programming side, we have got AWS CDK, the Cloud Development Kit, which supports JavaScript, TypeScript. I don't think it supports Go. It supports Python, C#, and Java, I think. So those are the examples. Again, the CDK only works with AWS. Okay. So that's a very quick introduction to both of these two tools. And this afternoon, I'll be showing you both of these two tools. So what we were doing is this: to work an example, to show you how these two pieces of software work. We will run through the hello world of IAC. Okay, we will be deploying a compute instance that is a virtual machine. We will attach some disk to it, a volume to it, and then we will install a public key, a SSH public key, so that we can SSH into the instance. and we will install Nginx. Nginx is a reverse proxy, a very simple, or not simple, but a web server, a reverse proxy. Okay, so this is like the hello world of IAC. Okay, so let's start off by doing Terraform first. Okay, so the way Terraform works is this, right? Because Terraform is cross-platform, what Terraform does is this. Terraform has got this concept of providers and resources. Providers are what you want to target, which platform you want to target. So for example, if you're using AWS, then you use the AWS provider, right? And the really cool thing about Terraform is this: you could use more than one provider in a project. So for example, you could provision an RDS in AWS and have the URL of the RDS, right, running on App Engine in GCP. Okay, so that's something that's really nice. So what I'm going to do is this: I'm going to use DigitalOcean. I think DigitalOcean is very nice because it's really simple to use. So it's really simple to use, and it's got quite a lot of features. So you search for a provider, which you get to a page like this, and you notice on the left-hand side, on the right-hand side here, you've got this tab, right? The first thing you need to do is this: you need to see how to configure the provider. This is what you do. This is what you need to pull down. So use provider. This is the documentation, right? You can also get the information from a provider up here by clicking on this. Okay, so this is how you create a provider. So what it says is this: this is what you need to do. Okay, so let us run through the example. So the first thing I will do is this: I've got two directories. The TF will be the Terraform. Okay, and again, this is how you structure your project. So what I will do is this: I will first of all create a file called providers. So the Terraform files end with a TF. Okay, and we need to write this thing. So we need to write a setting. So the thing goes like this: Terraform. Okay. Oops. So Terraform, right? And then the second thing that we need is that we will say required version. So what is the version of Terraform that we are using? And you can check this. You can just type Terraform. You need to install a Terraform. It's just got one binary. Okay, so that's the version I'm on. Again, it uses semantic versioning. So you can say, anything that's greater than 0.15.1, for example, right? Or 0. So this is the version. It's a best practice. It's not required, but it's a good practice. The second one we need to say is what are the providers that we're going to use. So required providers. PROVID providers. Yes. Okay. So now you say we are going to use the DigitalOcean. This is how you set up the DigitalOcean. Okay. You say the source. Say the source. So the source is going to be DigitalOcean. This is essentially the name of the provider. So everything in here you just copy, right? And this is the version. The version is 2.2.8.0. Okay, like this. So that's the first provider. The second provider I'm going to use is something called local. I'm going to use it to create some files afterwards. So this is the second one. The local. Let me show you how the local provider looks like. So this is the local provider. It's for writing out files, right? And so it's very simple. It's just HashiCorp local 210. Local equals to source HashiCorp and then local. Okay, and then the version is 2.1.0. Okay, so this is what we are telling Terraform that these are the two providers that we need. The second thing we need to do is this: we will now need to configure the provider. So the configure provider, let's go back to DigitalOcean. The local provider is very simple. There are no configuration. So the way you write it is like this: you go provider, and then the name, which is local, Let's go like this. Okay, so that's the local provider configure. Then we're going to configure the DigitalOcean. So the provider, DigitalOcean, like that. So we'll look at the DigitalOcean configuration. Okay. So the DigitalOcean configuration require these are the other information. The DigitalOcean, at the very bare minimum, you need a token. This is the API token, okay, the access token. If you're on AWS, you need to go and generate a token. Okay, so you need to configure the token. Okay, so you need to put the token here. Okay, so to make this flexible, generally what people will do is this, just like programming, right? You don't, first of all, you do not hard code your token in here, because if you hard code your token in here, you check the code in, you will lose, your token will be exposed to GitHub, right? So generally what people do is this, people create a variable. Okay, so I'm going to create a variable. I'm going to call it variables file. So that's a variables file. Okay, so I'll create a variable. Again, you do not have to split it up like this. You can put all of them into one file. I just like to split it up. I will call it DO token. Okay, so this is the name of the variable. The type will be a string. Okay, and because it's a token, I could tell, I can tell Terraform that this is a sensitive data. So when you're displaying it, please be careful, redact it, if you have to. Okay, so the way to do that is to go sensitive equals to true. Okay, there are other things you can put in here as well. You can do validation and also all that stuff. So this is the token. So I've just declared a token. I just declared a variable, and the way you use it here is like this. Okay, you go var dot. So the var is the variable namespace. Var is the variable namespace, and then you just put the name of the variable, which is DO token. Okay, so like that. Okay, so there are a few ways that you can pass the value in here. Okay, I will use the easiest way, which is to create. I'll use the easiest way, which is to create a file called Terraform dfvars. Okay, so this is where you will put your variables. You will put the value of the variables. Okay, like this. Okay, so this is my digital token, DigitalOcean token. I'll be deleting this after this demo. Okay, so this is the value. Another way to enter this value is when you run the script. If Terraform cannot resolve the token, it will prompt you for it. So there are a few ways. You can enter it through a command line. You can pass in through environment variable, etc. So this is what I'm going to do. So if you do like this, right, terraform.tfvars, Terraform will automatically pick up the values from here. So very, very important, terraform.vars should not be committed to your GitHub, to your Git repository. So in your Git ignore, you have to ignore, you should ignore the tfvars, right? Or you can split them up. So there are a lot of ways to create these variable files. You can split them up. You can put all the sensitive information in one file, right? And then ignore that file. But other variables, you can check them into your source repository. So there are many options to do this. Okay. So let's go back to our providers. So those are our providers. So once you have done this, right, you can now initialize your project. So we go initialize our project. So you need to run this once. So you run Terraform init once. What it's doing is this: it is now going to the Terraform to the HashiCorp, the repository, and start pulling down, pulling down the providers. So after you have done this, right, you will notice that they've got these files like Terraform. This is the thing that's created, the log file. this is like our exactly what version of the providers, right? So one thing you can do is this: if you want to git ignore, you should git ignore this, but not this, so you can reproduce the environment. Okay, so I've done this. So once we have got this right, so we have defined the variable. The next thing we'll do is this: we will now create our. Let's go back to our slide. Okay, we will now create the key, the key resource, and the volume. Okay, DigitalOcean allows you to the DigitalOcean provider again. Let me just move this so that I don't keep on hitting that thing. Okay, so the DigitalOcean provider allows you to load SSH keys. Okay, to load SSH keys. So what I'll do is this: I will create a local SSH key. Okay, or if you got something that that is created in DigitalOcean, you can load that, right? I'll load one locally. So to do that, what I'll do is this: I will go and I use my SSH keygen to generate a key, a key pair, and then I'll say it's RSA key. I'll write it up to a file called my key. I'm not going to put any passphrase. Okay, so those are my two keys, my key and pub. So this is my key is my private key, and then the pub, that's the public key. So this is the public key that I'm going to need. I'm going to install this public key on the VM that I'll be provisioning so that I can SSH in. Okay, so I will now create a file called resources. Again, remember, right? The file structure is totally up to you. I just like it like this. I just like to structure it like this. So we're going to use the first thing we'll do is that we will load our key first. The way the resource is created is very simple. All of them has got this structure. The name of the resource. This is a keyword. This is the provider resource, DigitalOcean resource, and then this is the name of this resource. Okay, so think of this like the type, right? And then this is the multiple instances, the name that you see when you provision to DigitalOcean. So you go like this: resource, okay, and then you say DigitalOcean SSH key. This is the older syntax. For the older HCL syntax, you need to you put a code. The newer syntax, you don't need to put a code. So you just do like this. Okay, and then I'll say my key. Okay. So you need to give a name. So I'll just put it the same name, my key. And then now this is the important one, which is the public key. Public key. The file here is a HCL function. I'm asking it to load the public key. This is the public key, right? So this is the resource. If we now provision this, if we now go Terraform, a plan, what you will do is this, right? It will say a plan basically means you ask Terraform to go out and check the resource. What do you need to do? So Terraform will say, okay, I need to create this particular resource, right? So I can now go ahead and say, if there is no mistake, I can go ahead and say apply, and then you say this is what I'm going to do. Are you sure? So you need to type yes here. So it's now going to go off and create the resource. So the resource has been created. So that's the first one. So the second thing I'm going to create, according to my plan, is I will create the volume. Okay, so I go resource. So the volume, you go to here. So look for volume. So I want volume. So this is the volume. Okay, so I will say resource, DigitalOcean volume. I will call this my volume. And then the name, again, my volume. Okay, so that's the name. in this case now, the volume I need to specify in a region, okay, and the volume and the VM that I'm going to provision has to be in the same region. So what I'll do is this, I'm going to create a variable for this guy. So I can say variable region. The type is string. Okay. I need to be sensitive. This is not like some secret key. I can provide a default value, and then I can get this overwritten, right? So I'll provide a default value. So the way you provide a default value is you go default. Okay, and the region I'm going to provision to is SGP1. This is one of the DigitalOcean's region, which is Singapore, right? So now I can come here, I can say region. Again, you need to follow this thing, right? Region. I will say var region. Because the next one is the size. Okay, so let me just fix this. I'll say size. So if I want to, I can go ahead and put here again. Okay, I'll say this is let's say volume size. Let's say the default, this is number. Let's say the default, is just 1, right? So now I can just say var volume size. Okay, so let's go and plan this guy. Oh, sorry, I need to do the initial file system as well. Okay, so this is the file system type ext for initial file system type. So I want ext4. This is the Linux file system type, right? So let's do a plan. So notice that Terraform is actually very smart because it knows that we have already provisioned the key. So it will not say it's going to add the key. It will now say, I'm going to provision the volume. So you see the volume only, right? So if you want to destroy everything and start again, you just go destroy. Okay. So now because it knows that only the key has been provisioned, not the volume, so you only destroy the key, only go ahead and destroy the key. Okay. So let's do a plan again. So now if you now see plan, it will now say that I need to deploy both of this. Okay. So I'll now say apply. Okay, and go ahead. So this is the idea of idempotent. Idempotent means that if something has been deployed, you ask Terraform to deploy again. Terraform will not deploy it because Terraform knows that it has already been deployed. Now I've got 2 of the resources deployed. Okay, so I've got this and I've got this. So now the final one is to deploy this instance, this compute instance. Okay, so this one will tie these 2 together. So what we'll do is this, we'll go resource. Let's go and look at a droplet. A droplet is DigitalOcean's way of saying EC2, right? If you're on AWS, you say EC2, right? So DigitalOcean is called droplet. Okay, so that's a droplet. Okay, this is the most simple. Simple droplet. So we will say DigitalOcean droplet and call it my droplet. And then the name, you can give it any name you want. I will call it my droplet. Okay. By the way, this name doesn't have to be the same as this name. Okay. And then the region, I'm going to use back the same thing. Let's go here. Okay, I'll use back the same thing. So both of them are on the same region. Then the next thing I will need to do, specify is the image. What image do you want? Okay, so the way you can get the image from DigitalOcean is, so DigitalOcean has got a few images. Again, you can get it from the command line. So I'm going to use the DigitalOcean command line, compute image list. Oops, hang on. help. List distribution. Sorry, compute list distribution. Okay. Compute. Oops. Compute list image public. What the hell is it? Let me just see. Sorry. List compute image. Okay, sorry. List distribution. Okay, so these are the distribution. And what I'm going to do is this. I'm going to grab the Ubuntu. So those are the Ubuntu images. I'm going to just grab the LTS, which is this guy. Okay, the last LTS. So Ubuntu 2004 x64. Again, let's put it in our variable. So I'll say variable. Okay, droplet image. The type will be a string. And then the default is going to be Ubuntu 2004 x64. Okay, so let's come back to here and we'll say image equals to var droplet image. And then the last one is the size. Again, we'll do the same thing. We'll say droplet size. So I'll just do here for YY. Size. And then I'll say small 1 GB, sorry, 1 vCPU, and then 1 GB. Okay, so that's the size. So this is our simplest droplet. So now what I want to do is this, I want to add this guy and this guy to here. Okay, so for that, what we will do is this. We will come to here. So SSH keys. So this is a list. So we do like this. So now we want to say, I want to reference this SSH key. So I will say DigitalOcean SSH key. So this one is the first part here. So you can have multiple keys, right? Now you dot the second key, dot my key, right? So under my key, let's go back to here. So what it wants is it wants the fingerprint of the key. You'll notice, right? For every resource, there is the argument. Argument is what you set to configure it. So these are arguments. And attributes. Attributes are after you have applied, after Terraform has provisioned the resource, the values that you get from it. That's the attribute. Okay, so this is the attribute. So notice that in the SSH key attribute, the one is the fingerprint. If you want the public key, this is the attribute. If you want the fingerprint, this is the attribute. So you just go fingerprint like that. Okay. So the next thing that it needs, that I'm going to need is I want the volume IDs. That's the volume that I will be attaching to the droplet. So volume IDs, right? Volume IDs. So that's the volume on top. So DigitalOcean volume. In this case, it's just ID. Okay. So now what we can do is this. Okay. We can now try, we go Terraform, apply again. Sorry, plan. And then it will now tell us, oops, oh, sorry, I forgot the name. DigitalOcean volume. So I need the name, my volume. ID. Okay. So now we go plan again. Right. So we will now see that because I provisioned the other two, right? So what I will get now is just the droplet. A lot of this information, it will not know. For example, like the IP address, it will not know until after it is provisioned, right? I'll get the public IP and the private IP, etc. Okay, so that's my fingerprint. Notice that it knows the fingerprint because I've already provisioned that, and it knows the volume ID. This is the volume ID for DigitalOcean. So let's apply this. So now it is going to provision this. So I'll say yes. Okay. So let's look at it. I can go docpl compute droplet list. So you'll now notice that it is actually provisioning. So that's the name. Let me make it smaller so that you can in one line. So notice that that's the droplet, the IP address, the public IP address, the private IP address, that much memory, right? One CPU, and the region. That's the image. Okay, let me make that bigger again. Okay, so this is still provisioning. It will probably take about a minute to get it up. Okay, so now it is done, and this is the public IP. Okay, so I can now actually SSH in, right? I can copy this guy. Okay, I can go SSH. So my key, remember my keys up here. Okay, so I can go SSH -I. My private key, and then for DigitalOcean is root. For I think for AWS, you need to find out what are the users that are enabled, right? So I can do it like this. So yes, so now I'm inside my instance. Okay, right? So let me show you a few tricks, right? Instead of coming here to get the IP address, right? Okay, what you can do in Terraform is you can do this. You can go output. Okay, give it a name. So what is it after your provision? What is it that you want to display? I can say my droplet IP address. Okay, and the value. So what is the value? The value that I want is the IP address of this guy, right? So same way to reference it, I would say DigitalOcean droplet dot the name of my droplet dot. So I need to find out what attribute is available to get the IP address. So this is the droplet. Go to attributes, and the IP address that I want is the IPv4 address. I can get the IPv6. I can get the private IP address, etc. So this is the information that I want. IPv4, IPv4 address. Okay. So now I can do this. I go Terraform plan. So you say it's going to create this resource, which is output. Notice that it will not re-provision my resource. You just run this, right? So now if I just run this, apply. Okay, so I'll just say yes. So that's my IP address out here. So now every time if I want the IP address, I can just go Terraform output. Okay, and then you just display the output. So you can have as many output as you want here. If you got multiple droplets, you can just list all of them here, and then you can just type Terraform output, and then you just list out all the output. For example, let's say if I want for some reason, I want the fingerprint of my public key, I could go like this. Output my key, right? fingerprint. By the way, this is just the name. You can give any name you want. Fingerprint. And then the value is just will be this. Let me just copy this guy here. Value. Oops. Okay, so like this. So now I do apply again. Okay, so you say that, notice that you say this output, this is this output. So now if I go output, so I'll get these two information. So output allows you to get from the output, get from this thing, any output you want, any output that is present. I mean, the resource provides, right? So I'm going to show you one last trick that I like to do. So notice that just now when I do SSH, right? I need to do this, and then I need to type this thing. This is the ID, and then this is the IP address, right? So one thing I like to do is this, right? I like to create a file of this thing. So let me show you what I mean. So if you recall just now, I loaded a provider called local. Okay. So what local allows me to do is local allows me to create files. So let's look at local again. So local allows me to create files. Okay. So like resource, local file, the name of your file, and then what is the content you want to put in, what is the name of the what is the file name. So let me do this. I can go resource. Okay. I'll go local file. That's this thing here. I will call this root at IP. Okay. I do not want any content. I just want the file name. So I go file name. Okay. I can say root at. This is string interpolation. So I can now say DigitalOcean droplet, my droplet dot IPv4 address. Okay. So now I will apply again. Okay. So now it's going to say it will create this file. This is the permission. You can change the permission, whatever. So I'll just say yes. So notice that now it's created this file here. The file is empty. Okay, there's nothing in it. The purpose of that is so that I can do this SSH -i my key root at 1. So I don't have to type. I just reference that. And now I'm in. Okay. So that's the first part. So we have now provision this guy, attach a volume to the droplet, and then added the public key to this so that I can SSH in. So we haven't actually installed Nginx. Okay, so let's turn our attention to this. There are a few ways that we can go about installing software or configuring a VM that we have just provisioned. Okay, the first and most obvious way is to actually build your own operating system image. With AMI, for example, or Docker, or VMware. Generally, what you do is that you take an operating system like Ubuntu, and then what you do is you load all the packages software that you need. For example, maybe your database, maybe your Java development environment, etc. in, and then create an image out of that. So this is your own custom image, right? You call it Java environment, Ubuntu Java, right? So when you provision, when you say image here, when you say image here, you can use your image. And so once the image has been provisioned, you get all the software along with it. However, sometimes doing this may actually take time. Okay, it may be quite long, right? So the second way to do it is to use something called user data. User data allows you to run a script during the early boot stages. So this script can be anything. That the script can be installing packages, configuring network interfaces, firewall rules, etc., etc. Okay, so that's the second way. And this one, we do it to get, you do it during the provisioning of the image. Okay. The third way is to use another tool. If you've got really, really complex, software setup, right? The third way is to use a configuration tool, something like Puppet or Ansible, right? And this third option is done after you have provisioned your resources. Okay, so in other words, the VM has to be up and running, and then you use Ansible to start provisioning the server, to start configuring the server. Okay, and the fourth way, and this one is, if you can't be bothered with doing this, the option 1, option 2, option 3, the fourth way is to use what in Terraform called provisioners. Okay, provisioners basically means you ask Terraform to SSH into the server. Okay, and then once it's in the server, you run a series of commands. So using the SSH session, you run command. You run a command. If you read the Ansible documentation, sorry, not Ansible. If you read the Terraform documentation, Terraform actually highly discourage this. Okay, so what I'm going to do is this. Sometimes it's just a very easy way to do it. So in this way, in this demo, I'm going to use that provisional way. So the way you work with provisioner is this. We will look for provisioner. Okay. So we'll look for, hang on, let's look for. The one that we want is called remote exec. Okay. And the way it works is like this. So in here, in this resource here, okay, in this resource here, you go provisioner, provisioner, remote exec. Okay, and then you say inline. These are the commands that you want to execute. Okay, and the list of commands. Okay, so the first thing I want to do is I want to update remember, I want to install Nginx, right? The purpose here is I want to install, our purpose is to install Nginx, right? So I want to go apt update. So this will update the packages on the server. So the next thing I need to run is I need to run apt install Nginx. Okay. So remember, right? If you actually use Ubuntu before, if you go apt install Nginx, Ubuntu will ask you, are you sure you want to proceed? Okay. So when you're running this provisioner, you cannot be prompt for you cannot be prompt for interaction. Everything has to happen because you're running it on the remote server, right? Otherwise, you just sit there and hang, right? So apt install has got this option called -y. So you put -y here, which will automatically just say install. Okay. And then the next thing you want to do is this, just to be safe, you want to start the service. Okay. Again, this is not Ansible. This is just Linux administration. Enable Nginx. And then I want to start Nginx. Okay. So these are the steps that I want to do. I need to tell the remote exec, right? Because remember, I'm going to SSH in, right? So I need to tell remote exec how to SSH in. And for that, I need something called a connection object. So provisional connection, I need a connection object. So the way you do a connection object is like this. You can either do it out here or inside the provisioner. I'll do it in here. Let me do it below here. So you say connection. Let me move this up a bit. Okay, so this is provisioner. I'll say connection. Okay. So the type of the connection is SSH. Okay. The user is root. So remember, we are using root right here. Root. Okay. The host. Okay. The host is ourself, right? Ourself. So it is like this. Self. This is a special word. Okay. Myself. IPv4 address. Okay, and then I need to supply the private key. Private key. So I'll use file to load it. So that's the private key. Okay. So let's try this. If I do this, if I go Terraform plan, okay, you'll notice that Terraform will actually say there are no changes. Because as far as Terraform is concerned, our instance has been provisioned. It doesn't really know about this. Unlike Ansible, it doesn't really know about the state of the configuration of the server. All it knows is that the server has been provisioned, right? It doesn't know how to look into the server to determine that, that the server needs configuration, because server currently, the VM currently do not have does not have Nginx installed. Okay, so in this case, Ansible can actually help us, but we are not using Ansible. So what I'm going to need to do is I'm going to force Terraform to recreate this thing. And the way I force Terraform to do it is go Terraform. Okay, taint. We're going to taint our instance. So this is the tainting. DigitalOcean droplet, my droplet. DigitalOcean droplet, my droplet. Okay, so I will taint this guy. Okay, so now if I run plan again, okay, you will now notice that Terraform will say, I'm going to destroy this instance, the droplet, and notice that also is also saying I will also destroy my local file, right? Because this file, right? This file is the IP address of this file is dependent on the instance, right? If the instance is recreated, there's a potentially the IP address will change. So right, so this one needs to be destroyed and to be recreated. And so this is what Terraform is telling me. So just before I proceed, Terraform actually tracks the dependencies. So if you look at here, right, before Terraform can create this droplet, right, it needs to first of all create this and this guy. Before it can create these two guys, it needs to know, for example, like this variable. Okay, so Terraform actually tracks this dependency, and the way it does that is this. You can actually look at the dependency by doing Terraform plan, graph. Okay, then I'm going to use something called dot to capture it. I will generate a PNG file of it. So this is the dependency graph that has been generated. You read the lowest one is the dependency. So our token, notice our token here. The provider is dependent on the token. My key, volume, and probably droplet is dependent on this guy. So this two is dependent on this. Droplet is dependent on these two resources. So this one draws out the dependency tree, right? So this is how Terraform works out what to deploy. So now let's go and recreate that. Okay, so I'll say yes. So Terraform, what Terraform will do is that Terraform will now delete this file, and then you recreate it again. So it's now destroying my instance. So this is now going to be destroyed. So give it a minute. This time around, it's going to run a little bit longer because we will have these things to to install. And hopefully we will be able to see it on our terminal here. So it's now recreating the resource. So while this is going on, let me see if there's any questions. If you got any questions, let me see if there's any questions. Check. Okay, what is the question? What is the local provider for? Local provider is for creating. So Alvin Ching asked, what is the local provider for? Local provider is for creating files, right? So let's go back to here. It's for creating this file. So notice this is the local provider for creating files. Okay. You can use local provider to create files. More in more advanced use cases, for example, let's say, for example, if you're using Terraform with Ansible, and you have used Terraform to provision a whole bunch of, just notice that it's now installing the Nginx, which are not before. Okay, so let me get back to your example. One use case for local providers. Let's imagine a case where you're using Terraform to provision a whole bunch of servers, right? Once you provision a whole bunch of servers, you want to use something like Ansible to install and to configure these servers, right? So the way Ansible works is that Ansible needs a list of IP address, which Ansible calls inventory. You can write a template file, pass your list of IP address to the local file provider, and get the template to format and to output to create a file using this IP address to generate an inventory file for Ansible to consume. Okay, so in other words, you're passing data from one stage, which is your Terraform stage. Use the Terraform template to generate an Ansible inventory, and then use the local file provider to write the IP address to a file to be consumed in your next stage by Ansible. So that's one use case of it. Okay, so this is now done. We can now take this IP address, and we will now go to here. And if you do this correctly, we will now see our Nginx. So this is the Nginx that's now currently running. Okay. So now we will destroy this. The way it destroys is go Terraform destroy, and then this will now destroy. So I'll say yes. In fact, there is a command line which you can set to skip this step. To skip the yes. Okay. So now it's now going to destroy all my resources. Okay. So hopefully that gives you a really very high overview of how Terraform works. Some of the main concepts in Terraform, like a provider, a resource, right? Variables, how to handle secrets, and finally, provisioners. Again, Terraform, in Terraform, what they advise is, provisioner should only be used as a last resort, right? So if you're doing what I'm doing, installing software, it's better if you're better off using another tool like Ansible to manage, your software. So that's Terraform. The next thing that we're going to do is that we're going to do the same thing, and I'll do it a little bit faster now. We'll now do Pulumi. Okay. Again, Pulumi is fairly easy to install. Just one command line. You need to log in. You need to create an account in Pulumi. Once you've installed Pulumi, you just type Pulumi. So that there are a few options here. You need to log in. So you type, you type Pulumi, new. Oops. Okay. Okay, it doesn't like this. What is this guy? Oh. Okay, so it doesn't like the directory not empty. Okay, so you go new, So it's saying that, you can actually set up like a project. It's saying, these are some of the templates that I've got. I will ask it to show additional templates. Obviously, these are the popular ones like AWS, the Azure, the GCP, the Kubernetes. So I'll show additional template. And then what I want is this, I want DigitalOcean. And let's do TypeScript. So this is the project name. Some description. The stack, this is running on Pulumi, the Pulumi stack. We'll just use dev. Okay, so this is the Pulumi file. I'm going to install one more thing. I'm going to install something called .env for my variables. Again, if you know JavaScript or TypeScript development, this is what you do. I'm going to because I'm using TypeScript, I'm going to import the type. Right. Okay. So let's have a look at the program. This is the Pulumi program. So let me import .env first. Okay. So let me just comment out these guys. Okay. I'll go a bit faster this time. So remember, the first thing we need to do is this. From the Terraform, we will create a SSH key, right? So we'll say const my key, it goes to new DigitalOcean SSH key. So you give the name of the key. This is my key. So this one, my key here is, if you recall in Terraform, we do something like this, right? We go resource DigitalOcean SSH key, my key, right? So my key is this guy here. Oops. And what you need to do is this, we need to pass it the public key. Okay. So the public key is, I will use the Node.js function called read file sync. Okay. The file is above, and then I need to convert this to a string for it to consume. So that's SSH key. The next one I'm going to create is, if you recall, again from the Terraform, is the volume. So my volume, DigitalOcean volume. Okay. The really nice thing about Pulumi is that, right, the variables actually mirrors Terraform. Okay. My volume. So let's have a look at the documentation for this guy. This is the Pulumi documentation. So my volume, the volume here. Okay, so you need the name. So again, you will notice that it's the same thing, right? So what I'll do is this, I will create an env file. Okay, I will say region SGP1, right? And then I will say remember volume size. So let's say 1. So to enable that, I will just go .env config, right? Just to load that guy. So now I will say region process env dot region. Okay. Okay. Right. So the next one that we will need is the size. So we'll say pass int process env volume size. Okay. parse it. So, oh, sorry, this is I need to do this. Okay. Okay. Otherwise, I can just put it up here. Just save some time. Because it's TypeScript is type, the region is called that. So I can just say here region. This, okay, right? So pass in. So this is the volume. Okay, pass in. Just in case you forgot to set, then you default to 1. The third one is the initial file system type. Initial file system type. So this is going to be ext4. Okay. So the next thing we will do is we will create the droplet. Again, the same thing. My droplet. Okay. So let's go back and see droplet. Okay. So this is the droplet. Notice again, it's very, very similar. So I'll just use region. Okay. In TypeScript, if the value and if the name of variable and the key is the same, you can just do this. Okay. So that should be okay. And then I'll say image. Okay. So let's go and do the same thing for that, the image. So I say drop let image equals to Ubuntu 20.04.x64. Okay, and then the droplet size is at small 1 vCPU 1 GB. Okay, so you may say region. Then the next one is the image. You can say process.env.droplet image. Okay, as so this is the droplet image, and then the what is the third one? The size. Process.env.droplet size. This one you need to put as droplet slug. That's the okay. So this is the same. So this is the region, the image, the size. We do the same thing for the keys, SSH keys. So SSH keys, a list. We'll say my key. We'll say fingerprint. We want fingerprint. Okay, and then finally, we want the volume IDs. Volume ID will go my volume ID. Okay. Okay. So this is basically the image, the instance. The problem is this, right? With Pulumi, you don't have this idea of a provisioner, right? So if you recall just now, we install stuff into our DigitalOcean droplet in Terraform using this thing called a provisioner, right? So, and also if you recall that I showed you that there are actually four different ways that you can get software into your instance. Okay, so previously in Pulumi, in Terraform, what I did was I used the provisioner. Okay, since Pulumi doesn't have this idea of a provisioner, and if I want to use a provisioner, what I really need to do is this: I need to install the SSH package from Node and then SSH in. Okay, so that makes it actually very, very difficult. So what I'll do is this: I will use user data. Okay, so I will set the user data script on the instance, and then get DigitalOcean to install do the installation for me. In fact, I could actually use the same strategy on Terraform just now. I just want to show you the provisioners. Okay. So the way we work is like this. We use user data here. Okay. So user data basically accepts a script, any bash script. Okay. However, user data also accepts something called cloud-init file format. So cloud-init. Cloud-init is really, really good because you write what you need to provision in this YAML format, okay, instead of writing script. So I'm going to very quickly write one simple one and then show you what it is. Okay, so I'm going to leave this here first, and let's go ahead. I'll write a file called config YAML, and I'm going to write a simple cloud-init script to install Nginx, to basically do what I did just now with the provisioner. In the cloud-init, right, script, the first line has got to be a hash, and then you say cloud config. So that's what you need to do. Okay. I think it's called cloud config. Yeah, so the first line. Okay, so there's a space between here. Okay. Then the second thing I want to do is this. I want to refresh the package. Remember, we did the update, right? So we go package update true. So this, we are now doing YAML. And then these are packages I want to install. I can just say Nginx. And then now the commands I'm going to run. The first command, if you recall, the package has been installed. I don't need to run, apt update, apt install. So these two has been taken care of. Now I'm going to run the command systemctl start Nginx, and then the second one is enabled. Okay. Just to be the same as just now, I think I put enable first and then start. It doesn't really matter. So this is the file. So now I will do this. I'll go read file sync. I will pass in my YAML file. Okay. And I'll do the same thing. I will write out the root. Okay, I'll go my droplet. Okay, IP4 address. Okay, because it's JavaScript, you need to use an apply. We need to use a promise here. So we go apply. You get the volume. So anytime when this address value become available, you will call apply. And in apply, what it will do is you'll just go write file sync. Write file sync. Okay. The name of the file, which I'll call root at the value here. Actually, let's call this IPv4. Okay. And the content, I'm not going to put anything. Okay. That's the, if you want to export the value, you can use like this, export const my droplet. So I can say my droplet IPv4 address. Okay, so this is the same as before. Okay, so let's run this guy. So I can say Pulumi preview. Preview is planned. Okay, and we'll now go up. Pulumi up. Okay, so I want to say yes. Install. So I'll let it install. We'll come back to this. So let's continue with our slide. So we'll come back to this. So we have always come to the end of the presentation. So let's do a quick comparison between the two, Terraform and Pulumi. What we notice is that in Terraform, again, this is based on my personal, judgment or my personal experience with it, right? So Terraform is declarative. Basically, you just say, I want this resource, I want this resource, I want this resource. Terraform will sort of, plan all that for you, right? Pulumi is declarative. It's declarative, but it also has imperative part like this. Okay, this part here is outside of Pulumi's control. This is not part of Pulumi. Pulumi is just this. Okay, whereas in Terraform, everything in Terraform, that every resource, every output is all under Terraform's control. Okay, so it can be good, it can be bad, because if you are a non-programmer, then you will find that Terraform is a lot easier to learn. It's very, very easy to learn. Okay, but if you are a non-programmer, picking up Pulumi, I think it's a little bit more difficult because you need to learn the language first. For example, like you need to know how to write a file, know how to read a file. Whereas in Terraform, you just go file, and everything is handled for you. Okay, so Pulumi, because it leverages a programming language, is more low level. Okay, Terraform has lots and lots of. But Terraform is more mature and it's got a very mature ecosystem. You can practically do everything with it. For example, in Terraform, I could provision a droplet, get an IP address, and publish that to GoDaddy. GoDaddy has a provider for Terraform, right? In Pulumi, it's not so simple. Having said that, there are packages for Pulumi, because Pulumi, if you're using TypeScript, it's just JavaScript and TypeScript package, right? So you could use those libraries, but those libraries are outside of Pulumi's control. Okay, so you don't get the full management like you get from Terraform. One thing I don't really like about Terraform is this: when your project grows big, there is really no type support. Again, I did not show more complex type. I only show you string. I did not show you complex types like maps and lists, and objects, right? So in Pulumi, you cannot really create objects and reuse the object. Everything you need to redefine over and over again. Whereas in Pulumi, because it's based on a language, you can create very, very complex object types, right? And reuse that over and over again. And the other really great thing about Pulumi is this: you can actually build libraries on top of Pulumi. You can create further abstraction, right? Whereas in Terraform, you cannot. Your abstraction is limited by what the providers provide. Okay, both of them supports really major cloud providers, and that's really good. Having said that, Pulumi doesn't really have a lot of providers or options as Terraform, but Pulumi does have a Terraform bridge. In other words, you can bridge from Pulumi to Terraform, although I have not used it, before. Okay, so let's very quickly see. So now that we have done, notice that we've got this root here. Okay, so I won't SSH in. We can do that. So let me just go and do this, and just wait for a while. Sometimes it takes. I must have made a mistake. Okay, so I made a mistake with my configuration. Anyway, I'm not going to do it because it's run. I'll fix it when I push it to the cloud. Somewhere in my config, I must have made an error. Okay, somewhere here, I must have made an error. Okay, so anyway, it should work. Okay. Okay, so what about Kubernetes? We have talked about using Terraform and using Pulumi. What about Kubernetes? As you know today, Kubernetes is another very popular way of provisioning applications. However, the real difference with Kubernetes is this, right? Kubernetes actually provides a set of abstraction over our resource. So in other words, here, so this is our resource. Instead of having AWS or GCP or Azure, Kubernetes actually occupies this layer. Okay, you may run Kubernetes on AWS, and AWS provides the Kubernetes managed instance, but really Kubernetes directly manages the servers and the network and the resources that it provisions, right? Okay, so Kubernetes has got its own ideas of resources. It has got its own ideas of memory. It's got its own ideas, concepts of firewall. It's got its own concepts of reverse proxy. For example, in Kubernetes, the reverse proxy is ingress. Okay, so you don't really deal with Nginx or HA proxy. You just deal with ingress. Although when you deploy, you pick what to deploy, but you don't have to worry about it because the Kubernetes administrator would have probably done all this for you, right? And also, Kubernetes is slightly different in that Kubernetes actually defines an execution model for application. When you're using Kubernetes, right, you're not so much worried about, what are the servers, how many CPUs, etc. You're more concerned with the applications. So your applications are defined in terms of pods, right, and how the container interact with each other, the configurations, etc. Okay, so if you look at it this way, right, and there are other frameworks that are built on top of Kubernetes, like your monitoring services, your service mesh, your serverless, your operations, etc. Also, if you look at Kubernetes, Kubernetes is really more like an IAC, infrastructure as code, for platform as a service. Whereas Terraform and Pulumi is more towards IAC on the IaaS, on the infrastructure as a service. Okay, so if you are only worried, if your concern is only about application and not really worried about the underlying hardware, then probably Kubernetes is a better option to go. Because in Kubernetes, you just focus on how your application is structured, right? Rather than installing software, installing patches and stuff like that. Although from my own personal note, both Terraform and Pulumi can provision Kubernetes resources. They do have, if you look at the provider for Terraform and Pulumi, both of them, has provisioners, providers for Kubernetes. But personally, my personal preference is that I prefer to write, native Kubernetes YML over, HCL or using a language to do it, because I find that Kubernetes YAML provides a lot more flexibility, a lot more power, a lot more control. And besides, Kubernetes has got stuff like Helm and customize and all those other things that you cannot really do very well in Terraform or using Pulumi. So if you're going to learn this stuff, right? So where do you start? Okay, if you look at the IAC tools, basically there are 3 layers, right? There is, first of all, the technologies. You have your servers, your networks, your network stack, your firewalls, your routers, your DNS, your Linux, your scripting, your topology, your network topologies, your SSL, TCP/IP, etc., etc. So all these tons of stuff, right? And then on top of all this stuff, you have got your cloud providers. You've got Azure, GCP, etc., right? And they virtualize all these technologies or all these resources underneath them, right? Your IAC tools sits on top of the cloud providers. Okay, so if you just learn, if you do not know this or this, if you do not know this layer or this layer, and you just learn this, you're not really doing yourself justice, because because this is just a tool to automate this, right? If you do not know this or you do not know this, you're not going to be able to automate. Okay, and a lot of times what I find is that when I'm doing work projects with Terraform or Ansible, basically I use this tool the most. You need to come up with creative ways of bridging from one to another, because very often I will find that something although as mature and as wide open as Terraform is, there's always something that I cannot get from Terraform. That is a time where you need to come up with, for example, like your Linux skills to figure out how to bridge across from Terraform to Ansible, right? Maybe generate some script. So for example, let me give you an example. An example is sometimes I generate a whole bunch of like I do here, right? I generate a whole bunch of this IP address for Ansible, right? And you use Ansible to connect. When you use Ansible to try to connect, right, Ansible will give an error because this IP address hasn't been trusted. So what you need to do is this: you need to from Terraform, you need to use Terraform to generate a script to automatically add all the IP address into your well-known host, and then run that before you can run Ansible. So you need to have all these little bridging steps, right? That may or may not be part of Terraform and Ansible. So the way to learn this, if you really want to get into ISO2 personally, you should start with technologies. And one of the main things you should actually do is you should actually learn Linux and scripting. These are the two probably most valuable skills that you will ever. Yeah, of course, the rest are important as for networks and stuff like that. But a lot of these are just Linux, because IAC tools, especially like what you see I do just now, is essentially Linux administration. Okay. So finally, before I end, IAC is really making sysadmin sexy again, right? Okay, so this guy, I'm not sure if you know, this guy is called Moss. It's actually from a British comedy called I cannot remember what is it called. Called IT Crowd. Okay, so it's about these two sysadmin that sits in a dungeon somewhere. So you should actually, I think they are on Netflix. If you're on Netflix, you can go and see them, right? Okay. So so that's the end of my presentation. What I'll do is this: I will push the code up to this. I will fix. Let me just try this again first to see if it's still working. Okay, looks like I made a mistake somewhere in there. So the thing isn't installed. I will fix that, and then I will push it up. I'll make a note and I'll push it up. So you can get the code from here. So before I end, what I want to do is I'd like to just take a very quick poll. Oops. I would like to take a very quick poll of what you would like for your next. Okay, this may not. I may not necessarily do this, but I just want a quick indication of what people would like to. What you would like to see, like to hear in the next, workshop. So please scan this one. You'd like to hear GitOps, Docker, developing a simple RESTful API with Golang or TensorFlow 101, or maybe don't bother, Yeah. Okay. So let's take a few minutes to do this poll. Again, I may or may not do this. Okay. I'm just taking interest. Probably the next workshop will be about in a month's time, maybe a month, slightly longer. Because I'm really cheapskate, I'm using something free. Only 100 of you can vote, but we have less than 100 people, so that's cool. Okay, so I'm going to give a few minutes. Okay, so RESTful API with Golang. Okay, seems to be the top one. Okay, so so let me keep it active. I'm going to keep it active. So thank you very much. I hope to see you